Hello, welcome back. So today we are diving into more advanced JavaScript. I know immediately you saw these closures, you will be so scared. Yes, closure can be very scary. So we'll be talking about closures today. The first time I saw this closure, I was like, what is this? As it took me, it was even recently that I got to understand what closure is. I have read so many books on it, so many articles on it. It was recently that I got to understand it. So I'll try my best to break it down so that you would understand it. So what is closure? Okay. What is closure? A closure is a function. A closure is a function that remembers, mark that word, remembers variables from its outer scope. Now, for you to really understand closure, you need to understand scope. We have discussed a scope before. We talked about global scope. We talked about function scope and block scope. But there's another one called lexical scope. All right, lexical scope. So now look at this definition. Take it one as in just break it down. It's a function that remembers variables from its outer scope. Remember, a function can also contain another function. So the inner function and the outer function. So the inner function is actually the closure because it has or it remembers or it has access to the outer scope. So now a closure is a function. Now, in this case, it has to be an inner function. All right. It has to be an inner function that remembers the variables from the outer scope. And in this case, it could also be the outer function, even after the outer function has finished executing. Okay, don't worry, I'm going to take it. I'm going to take my time to explain this. When we get into code, you're going to see more of this. Even after the outer function has finished executing. Now, that is where lexical scope actually comes in. So don't worry, I'm not going to rush into that. Let's continue. This is one of the most powerful features of JavaScript, enabling encapsulation, memorization, and private variables. Okay. Don't get confused. Don't get bothered. Even if you don't understand what I've explained so far, don't worry. Let us continue. I will explain more. All right. So now, every time a function is created inside another function, it forms a closure. Let me show you an example. So I'm going to take everything. So now let's say we have this function. Oh, my bad. We have this function. Okay. I will call the function outer. Okay. This outer function, um, let's assume that this function has a variable called count, and the count is from zero, we're starting from zero. And now we have another function. We can say we have another inner function. Sorry. We have inner, all right. This inner can actually do something with this outer function. This inner function can actually do what? Let's say count plus plus, count plus plus. So we are incrementing. So look at it. This inner function has a closure over. Remember, what is wrong with my code? Something is wrong. Oh God, okay. I didn't use the keyword function. Okay. So now remember, this inner function, this inner function has access to the outer function. Now, this is the outer scope. This is for the enclosing scope. That's the first function scope. And everything inside of here can be accessed by the inner function. Why? Because this inner function have access to everything inside of here. So that is why we were able to have access this count. And what we are doing in here, inside here is that we are incrementing it. Now, if we try to say, okay, let us return this inner function. Let us return this function. Okay, so if I go on now and say, okay, if I go on now and call and say outer this outer function, remember, look at the declaration, the definition of this outer function. It's returning something. So now let us say whatever is returning, let us save it. So I can say const, I can just say inner one. I can say inner one. All right. So remember that the outer function is returning something. Look at it, it's returning something. The outer function is returning something. So whenever we call this outer function, it's going to return this inner. And at the end of the day, if I go on now and call this inner is a function, remember it's returning a function. So that means this is a function expression. I can now go and call it. I can say, if I now say inner, if I say inner function, if I call it like this, it's going to increment. Okay, so this is what I'm going to do. So inside here, let us just console.log it. Do you understand? Because it's not going to make sense. Okay, so now look at what I'm doing here. This outer function returns something else, which is a function. So as we call this outer function, we are returning it and we saved it. Whatever is returning, we are saving it in this variable. And remember, since it's a function that is being returned, we can also call it. Now, if I call this function, all right, look at it. If I save it and call this and run this code, you can see, it incremented it to 1. So we call this outer function. This outer function return this the inner one. It returns something and we saved it in inner one, and we are calling the inner one. Okay. So every time we call this outer function, all right, every time we call this outer function, it is going to return a function that would remember the discount variable and then increment it. So if I go on now and say and call inner function again, let's see what happens. If I go on and call inner function again, you can see it's incrementing. Do you understand? If I go on and call it again, again and again and again and again, it will keep on incrementing. So what is happening? What is happening? This is closure. If I run again, you can see 1, 2, 3, 4, 5. So it is incrementing it. So what exactly is happening here? This, our inner function, has access to the count. But look at it. We are no longer, this count is supposed to be accessed normally. Now, normally, what we talked about scope is that this variable is supposed to be accessed only from this scope. But even though the outer function has been called, even after the outer function has executed, though, nothing concerning them again, it has executed. But we are still having access to its variable. This variable is local to the outer function. And after executing the outer function, normally, I don't know if you understand call stack. Whenever you're calling functions that are being added to the call stack, and whenever the function finish executing, they will be removed from the call stack, all their variables, everything, they will be removed. But in this case, we are still having access to the counter, even though we are no longer calling this inner function from the scope of this outer function. Now, this is what we mean by closure. Okay, this is called lexical scope. Lexical scope is different in the sense that lexical scope has to do with, lexical scope doesn't deal with where you're calling the function or where you're executing the code. Lexical scope has to do with where was that variable or where was that function created or declared. So if you take a look at this, is where the count function that we are using here, remember we are not using outside of here, it is created inside of here. And why this count is not going to go away is because the inner function is referencing it. I don't know how, see, this can be very confusing. But the best thing you need to understand here is that this inner function is a closure because it remembers this variable, the variable inside of its outer scope. It remembers it, even though the outer function has finished executing. Let's go back to that definition again. A closure is a function that remembers variables from its outer scope. Remember, this is outer, that's enclosing scope. So in this case, we are remembering the count function, sorry, the count variable, even after the outer function has finished executing. If you take a look at our code, you will see that the outer function here has done its job. It has finished executing, but yet we are still having access to the count variable. All right, let's say this is some magic JavaScript actually have. Let's say it's some magic. So try to understand this magic, okay? But it's okay if you don't grab it at first. Maybe you can even rewatch this video and maybe do some, as we go on, you get to understand better. But don't beat yourself up, okay? It's very hard to grab this thing the first time. So let's continue. Okay, so this is the syntax illustration. Already, I've already done that. Look at it. We have the outer function and we have the inner function. And the inner function is having access to the message variable here. Okay, so here when we call the outer function, it's returning something which is it's returning a function. Then we are saving whatever is returning in this variable called inner func, and then we are calling this inner func as a function. And once you call it, it's going to what it's doing here is just saying console.log the message. So this message is still available for this inner function, even though this variable, the scope where that variable exists is no longer in the context. Do you understand? So, even though outer function has finished executing, inner func remembers the message variable. So these are key concepts you need to understand um, about closure. The lexical scope, closures depend on the scope in which a function is defined, not where it is called. If you watch our the closure, that our inner function, it is dependent on the lexical scope, it's not dependent on the function scope or the scope where the variable was declared. No, it's dependent on the lexical scope. There are books I recommended you to read. You should read them. Another book you should also try to read is You Don't Know JavaScript. Why DKS? Okay, if you don't have that book, ask me for it and I'll give it to you. All right. See, for you to really get advanced in JavaScript, you need to be reading this kind of books. Take your time and read them and understand them. Okay. It is actually when I got to understand lexical scope that I got to understand closures better. This is not even the first time I'm teaching closure, but this time around, I understood it better and I'm teaching it better. So private variables is another concept you need to understand when you're dealing with closures. Variables in the outer function are hidden from the global scope, but they are accessible inside the inner function. Take a look at what we have here. This count is a local variable, it's a private variable. When you take a look at this scope, the global scope cannot have access to it, but the inner function has access to it because both of them are within the same scope. Okay? They are within the same scope. Even though we are using the let keyword, that is not function scope, the let keyword is block scope. So we have this block here. So that is why the inner function is also having access to it. But this can be very interesting if you get to understand this, I'm telling you. So another concept you need to understand is memory efficiency. Closures allow keeping certain data in memory for use later without exposing it globally. Like I was talking about, normally, after this outer function has executed, this inner function, this count variable is supposed to go with it. It's supposed to be removed from the core stack. But because we have a closure here, that remembers it or that is making reference to it, that closes over it, all right, that remembers it and is making use of it. It will be in memory. It will not go out. Had it been this inner function is not making reference to it, or it's not even returned or something like that, the count variable would have gone from memory. Okay, so it is not available to the global scope, but it's available to the inner scope. So let's take a look at some practical examples. We have done the first one. We have done count. That's what we have just done already. We have just done count. Okay, but in this case now, we are doing it differently. We are inside of the count, we are returning inside of the inner function. We are just returning a function. It doesn't have any name. It's an anonymous function. So, but always try to give your functions names. Try your best to always give your functions names. Now you might not need it now, but when you get into doing more debugging, your code has some issues. That is where you get to understand what I'm talking about. So for now, you might not even notice it, but just make it a habit that always give your functions names. Okay. So return this. Look at what we are having here. This function is returning another function. And this function that is returning is having access to the count variable and is incrementing it. And the outer function is returning a function that is returning the count. All right. So now if you go on and call the outer function, the counter function, remember it's returning a function all right, which is this, which we are storing here in this increment variable. So when we now go and call the increment variable, it is going to return the count, which is in this case now it has been incremented by 1. All right, if you call it again, it increments it because now the first time this increment function is called, no, the first time the count was 0, then it incremented it, it became 1, it returned it. Second time, count was 1, it incremented it, became 2, it returned it. If you call it again, count will be 2, it will increment it and it will return a 3. Okay, so the count variable here is private to the counter function and cannot be modified directly outside of the scope of this counter function. You cannot modify the count variable. Okay. So I don't know, do you still need me to do this? Okay, let's go and just do it. It's different from what I already had here. So I'm going to say counter. I'll say counter. And then I am not, like I said, I just like return. I think this will be the okay. Now instead of consoling dot logging it, we will just return the count. And then we can even return, it's still the same thing, what we are doing here, and instead of doing it here, we are doing it here. So I don't know. So okay, we can do this, and then maybe we can also remove the name here. All right, so look at what we have now. Okay, so if I go on now and say, okay, since I know the counter returns a function, I will just call it increment because that's what it does. It increments the variable. Then I'll say counter. Then I'll call this counter. Okay. Now, if I go on, and I have the return value of the counter function, which is also a function. So if I go on now and call it, if I say increment, if I go on and call it, remember this increment function is also returning a variable. So let's go and store that variable. So instead of storing it, we can just console.log it. Okay, we can just console.log it. I hope you understand what I'm doing here. Instead of saving it, console.log, and so in this case now, I can go on and console.log this thing several times, and it will just be incrementing that variable. So if I save now, and go on and call it. You can see I called it 4 times and it incremented it 4 times. So the first time the count variable was 0. So it incremented. So look at what happened here. We call this counter function. So this counter function was executed, and after the execution, it returned another function for us. That's what we have here. So now we call the increment function. It's a function expression. All right, we called it as a function. So the moment we called it, it will come in here. So it will come in here. The first time count is 0. All right, so it will increment it, it becomes 1, a return count. That's the return value is what we are logging. That's what we are that's what we are logging. Okay, now it becomes 1. Okay, so that's it printed 1. So the next time we call this line again, so it will come in here and check. It's still remembering the value. That is closure for you. It remembers the value. Remember after the first call, it became 1. So 1, if you increment 1, you get 2. That's why we got 2. Then if you call it again, it will increment it. It will keep on incrementing it like that. So that's the counter example here. So this is pure closure. This is pure closure. Okay. So we also have another one, function factory. So recently, there's this interview I did, and they were asking me about closure, and they were asking me as in what are the uses or where do you use closure. So you use closure, one of the places you use closure is function factory, data privacy, that's encapsulation. You also use it in React, memoization. You use it in event handlers. Do you understand? So, but we'll still talk about them here. So function factory is that we are going to use a function to create a fact. As our function is going to be like factory. We are using our function to manufacture things. So function factory is like function where we are producing objects. So closures allow creating customized functions dynamically. So look at this function here. multiply by. Okay, so our multiply by is the outer function. So it takes a parameter x. So it will return another function that would also take another parameter. But look at the implementation of this in the inner function is going to return s and y. Okay, so this is function factory. So that let me just let's go and demonstrate it here. So I will take this off. If you want to, if you have not, you can pause the video and take a look at it, but I'm going to take it off. So I will have function and I'll call it multiplier. So this multiplier will take in any, this will be the base case. So it will take in x. So if you want to multiply something by something, this is the multiplier. So this multiplier is going to return another function. Uh, we're not going to give it a name. It will return this function, but this function will take in another variable y. Then this our inner function is returning x multiplied by y. So what do you think now? Yeah, what do you think? First of all, when we call this multiplier function with a variable, it will return a function, and then we can now call that function with another parameter. Sorry, I mean parameter or argument. I will call it with another argument. It will now give us this result. So we are going to have, let's say now we want to have multiples of 2 or multiples of 3 or multiples of 5. This is where this would actually help us. So if I go on now and say console const, I can say um, um, multi multiply by 2. All right. Then I'm going to call the multiplier function and I'm going to give it 2. So what am I doing? This multiply by 2 will be multiplying anything we give it by 2. So if I now say console.log, and then I called multiply by 2. If I call it with, let's say, 3, all right? And then I will call it with 3, I will call it with 4, I will call it with 5, okay? Okay, so I will call it with 4, and I'll call it with 5. So if I save now, look at what we are doing here. If I go on and run this code, this is what it gave us. He gave us 6, 8, 10. So our base, look at our function, our base multiplier is 2. So 2 times 3 will give us 6. 2 times 4 will give us 8. 2 times 5 will give us 3. I can also change this base here. I can change it to 3. So I could also have changed the name to multiply by 3, but there's no need. I'm just get the example. So I am in the second this time around I'm multiplying by 3. So it's going to multiply by 3 times 3, 3 times 4, 3 times 5. All right. If I go on and do 4, it will do the same thing. I'm multiplying by 4. I save. All right. Look at it. It's multiplying by 4. So you can see that we are having a base. This is a factory, function factory. We gave it the base, all right, and then we can now multiply it or we can produce more from that base. Okay, don't get confused. Try your best not to get confused. So you Okay, so you can see we could have different multipliers here. All you have to do is to give it that base, and we can use it to create. It's like you give it an input, you can use it to multiply or manufacture a lot of things. That's function factory. Okay, all right. So the next example we could have here is encapsulation. So we can use closures to create, we can use it to mimic the way Java, C++, C Sharp, the way they actually create encapsulation, we can use closure to mimic that. So look at this example here. We have a function called bank account. It will take the initial balance. So with this initial balance, we will use it to create an account for somebody, bank account for somebody. These are kind of interview questions. So now take a look at what we are doing here. We are So another example we could also have is look at this example, encapsulation and private method. I told you one of the use cases of enclosure is privacy, data privacy. So look at this function. This function is called the bank account and it takes an initial balance. So at the end of the day, this function is returning an object. It's no longer returning a function, it's returning an object. But if you take a look at the object is returning here, you can see that we have this deposit and we have this withdraw. Both of them even get balance. Both of them are functions. So now let's go and do this. We have a bank account function. It takes an initial balance. Then we have this variable let balance equal to initial balance. Then we now return an object deposit. Balance could be plus equal to amount withdrawal. If amount, okay, let's get into it. So now I'm doing this. So I have this function. It's called um, bank account. This is going to be a constructor function, and it takes an initial balance as parameter. It is an initial balance as parameter, and then we are having this balance as our local variable, private variable. So we will assign it to initial balance. So once the user creates this account, all right, and have the initial balance, they can't have access to it outside of the function. So I'm returning an object. Okay, so inside of this object, I'm going to have functions. The first function I'm going to have is deposit. All right. So this deposit is going to be an arrow function, all right, that returns, I hope my code is not going to confuse you. It returns balance plus equal to amount. So this is an arrow function, and I just have it since I am not doing more than one line. I'm doing this here. So the another one is withdrawal. Withdrawal. Withdrawal is also this. So this withdrawal will take amounts, okay? And then I'm not going to do a one-line this thing here. I'm going to, okay? So I'm going to check if there's a constraint here, there's a validation here. If amount is less than balance, there's no way now we cannot do anything. So we could just say return, or we can just say console.log. Okay, you can implement it in any way you want to. So this is not, you can implement it any way you want to. We can say insufficient fund, right? Insufficient. I don't know if my spelling is correct. Insufficient balance, something like that. But if it is not true, if it's not less than, we can now say balance minus equal to amount. Okay, so let me go to the slide and see if I have the implementation correct. Okay, so if withdrawal is less than or equal to balance, we say else consider, okay, it's basically the same thing that I'm doing here. If amount is less than balance, if amount is less than, oh, sorry, okay, sorry. I should say if amount is greater than balance, because amount can never be greater than balance. But if it is equal to or less than balance, then we can do this. Okay. Uh, oh, no, we should use the else here. I think, yes, we should use the else because if not, it will fall through or something like that. Okay, so my bad. We should use the else statement here. We should use the else statement here. So that it can only do one, not both. All right, so well done, well done. Then the next one I have is so if you want to now get balance, you can now do this. So this get balance is it's also a function that will just return, it will return balance for us. Okay, so now we have this code. We have our code, and so this is what we have. So if I now go on now, and I'll say const um, savings account is equal to, I'm going to create a bank account and I'm giving it 2,000. So that's the initial balance. So the moment I call this function like this, the initial balance is what we have given as 2,000. Then the balance here will be assigned to the initial balance will be assigned to the balance. That's what we are working with here. So now there's no way. If you try to now say savings, look at it. Savings dot balance, you cannot get it. It will throw an error. Look at it. If I save it and run this code, it will throw an error because it's not. Look at it. You can't get it. You can't get it. It's not. Okay, wait. If I say console.log, it say undefined. It's not possible. You cannot get it. You can't get it. Okay. So now, if you want to get it, you have to use the get balance. We have the get balance. We have the get balance method. We have the get balance method. So if I run it now, it will give us the balance as 2,000. All right. So if I want to deposit, I will now say deposit, and I'll give the amount I want to deposit. I want to deposit 1,000. And then if I try to say, after doing that, I could say console.log um, savings dot get balance. So after depositing, I want to also check the balance. So if I run it, oh, we have an error. Okay, so something is wrong. It says amount is not defined. Oh, sorry. Sorry. Yes. Look at what I did. This amount was they were looking for it and they didn't find it. And I'm supposed to actually, it was supposed to be a parameter here. So if I go on now and run this code again, you can see, is this still saying the same thing? You can see, okay? You can see it's 3,000. Okay. So if I call again, it's 3,000. So deposit. Okay. Okay, you know what? You know why this thing is calling? You know why this thing is calling two times? Because I was wondering. It's because of here we are saying return, we are returning this. So that is not what we're supposed to do. We're just supposed to do this. We are supposed to do it like this. So you see, my logic was very, very wrong, but it's fixed now. So we are no longer returning. We are not returning that. So if I save it now and run it again, we only have that 3,000 printed ones. It says undefined. Okay, sorry. We are not supposed to be calling it. No wonder. I'm not supposed to say console.log savings. It's a method that does not return anything. So if I save it again and run it, we only get this. This is the only place we are printing something. Okay. So you can also try withdraw one. Instead of doing deposit, I can say I want the initial balance is 2,000, but I want to withdraw. I want to withdraw 1,000, and after that, I want to check the balance. So if I click now, you see, it has withdrawn 1,000 from 2,000, and the balance is now 1,000. All right. So this is exactly what we have done so far. Okay, so balance cannot be modified outside the return method. You cannot. So this is privacy, data privacy. Okay. All right. This mimics private method variables in other languages like Java, C++, C Sharp. All right. So closures in loops. You can also find closures in loops. I don't know if I should go ahead to explain this code. I don't know. I'm afraid it might cause some problems. Okay. I think I will leave it. 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 Uh, The best thing I would explain here is that if you have any function, so there is this function, this loop here will cause a problem. Your code, this code will not run as expected. Let me just cut it that way. The best thing you should do is always use let keyword in your for loops. That is the best thing. That is how we fixed it. So this is the way we fixed it. Always use let instead of var. Please use let keyword. I don't want to go into details explaining why it was a problem or it was not a problem because it could cause more confusion, but just avoid using var. When you have something like this, just avoid using var, okay? So we could also use this. I believe from the example I've given you already, you could also understand this. So we also have a function, all right? We also have a function. This is immediately invoked function, immediately invoked um, function expression, okay? Okay, so now we are returning an object. So if we call this function, it's going to return that object. So we can now do that object dot increment, object dot decrement, object dot, just the same thing we did with the other bank account. Okay, so you can also take a look at this code. All right, take a look at this code. Take a look at this code. It's a function, okay, and we are having a catch object here. So we are returning n. Okay, if we have the catch of n, so this is actually catching. We are using it to do mimic catching. So we have this object. So we are returning a function. All right. So when we call this function with a value or an item, a value, we will first of all check is that value, is it already in our object? If it's not, if it is already in our object, we will return the value. If it is not, we will just add it as a key and give it a value of n plus 10. And then we will return this catch object. I want you to take a look at this code and see if you understand it. The reason why you will not understand this code is that if you don't understand objects very well. If you don't understand objects very well, then you might not understand this code. If you understand objects very well, you understand this code. All right. So this is just after calling it, we are now using the function. Okay. So it's also used in event handlers to store state between event triggers. Okay, so this is the challenge I'm going to give you. Simple closure practice. Create a function called greeting that will return a function that returns hello plus the person's name. Right? This is your challenge. Your second challenge is the counter function. Create a counter function that returns three methods: increment, decrement, and reset. That means the increment should increment the value, decrement should decrease the value, and reset should reset it back to the initial value, maybe 0 or 1. I don't know what the initial value could be for you. Okay, so we also have another challenge here. Write a function that returns a multiplier function for any number. I've already done these examples already. A closure in loops, print numbers 1 to 5 after 1 second using the var, fixing using the closure or let. That's that problem I said I didn't want to go into, but you can just try it. If you couldn't get it, no problem, just leave it. All right. I wouldn't want to give you more than what you can carry now. You can also create a closure-based function to create the Fibonacci numbers. Try your best to do all these things. Okay. All right. So these are common interview questions. What is a closure and how does it work in JavaScript? You should answer these questions. How is lexical scoping related to closures? You should find a way to answer this question. How can closures be used to implement private variables? I just showed you that. All right. What's the difference between closures and object properties for storing data? And how do closures affect memory management? So implement a counter with increment and reset. You use the closure to create a multiplier function. Okay, fix this loop problem. All right, so the best thing here is to just use the let keyword. That's the best way to fix it. Very simple. Then implement memorization using closures, okay? So thank you very much. Create a bank account object with private. We have already done most of these things, so you can just go and do it yourself now. So thank you very much, and I'll see you in the next class.